Okay, so in today's video we want to look at the quotient rule. So the quotient rule is used to differentiate the ratio of two differentiable functions. So let's look at how to derive the formula. So of course we want to differentiate something like this. So what we'll do is we'll use the fact that we know the product rule and the chain rule. So what we'll do is we'll write this as the product of f of x and g of x to the negative 1. Then the product rule says that this becomes d on dx of f of x times g of x to the negative 1 plus f of x times d on dx of g of x to the negative 1. Now d on dx of f of x, that's just f prime of x, and we can write g of x to the negative 1 as g of x in the denominator. Now here we'll have an f of x out the front, and then the chain rule says to bring the minus 1 down, we differentiate the inside, so we'll get g prime of x, and then we'll have g of x to the negative 2. So if we simplify this a little more, we'll get f prime of x over g of x. Then we'll end up with a minus f of x g prime of x over g of x squared. But now if we have a common denominator, we just need to make the g of x the same in the denominator. So I'll have g of x f prime of x minus f of x g prime of x all over g of x squared. And so maybe we can write a little more condensed form. So I can write the derivative of f over g as f prime g minus g prime f over g squared. Notice that this is certainly not the same as the derivative of g over f. So the product rule commutes, but the quotient rule certainly does not commute. Okay, so let's have a look at some examples. So here's our first example. We'll look at tan x. The reason why we can use the quotient rule to differentiate tan x is because tan x is the same as the ratio of sine x and cos x. So let's bring this formula down to remind us of the form. So here we know that f, well, maybe we should probably call this u of x. That's maybe a more convenient notation. And then here the f of x, the u of x will be there. Okay, so in our case, f of x is sine x, and the derivative of sine x is of course cos x, and the g of x is cos x with g prime of x being minus sine x. Okay, so now we'll plug it into the formula, and we see that d on dx of tan x is, well, we first differentiate the top function, so we'll get cos x, leave the denominator function alone, so again have cos x, minus g prime, which is minus sine of x, and then f, that was sine of x, all divided by g squared, but g is cos, so this is cos squared of x. But now this just becomes cos squared x plus sine squared x over cos squared x. But by the Pythagorean identity, we know that sine squared plus cosine squared is 1. So we get cos squared x in the denominator, and we can just write this as sec squared x. Okay, let's look at another example. So here we have f of x is e to the x, and the denominator is 1 plus log e x. So we could also replace f and g with u and v. That's another common thing to do. So u is e to the x, so u prime is e to the x. V is 1 plus log e x, so v prime is 1 over x. And so by the quotient rule, we differentiate the top function first, leave the second one alone, minus the derivative of the bottom function, leaving the first one alone, and dividing by v squared. We can simplify this a little bit by maybe pulling out an e to the x out the front, and then we'll have 1 minus 1 over x plus log e x, all divided by 1 plus log e x squared. Okay, one more example. So here we have u being 1 plus 4 log e of 1 minus x. So in particular, u prime will be minus 4 on 1 minus x. V is 2 plus sine 8x. So v prime will be 8 cos 8x. And so by the quotient rule, what we'll find is we get minus 4 over 1 minus x. So we differentiate the top function, leave the second one alone, minus 8 cos 8x, and leave the top function alone, all divided by 2 plus sine 8x squared. And since that's not going to really simplify much, I think we'll just leave it there. So just to recap, the quotient rule is given by first differentiating the top function, leaving the second one alone, subtracting the derivative of the bottom function, leaving the first one alone, and then dividing by the square of the denominator. This is derived by, well, one way to derive it is to use the product rule and the chain rule. And we looked at 3 examples. One in particular doesn't appear to be a quotient, but does in fact require the quotient rule to differentiate. Okay, if you like the video, please hit the like button and consider subscribing if you're new to the channel. There will be notes in the video description down below, and if you have any questions, you can leave them in the comments section down below also. Thanks guys, I'll see you in the next video.